This is SpaceTime, Series 22, Episode 13. Coming up on SpaceTime, a new date for the Milky Way's expected collision with Andromeda, distant moons may harbour life, and scientists observe a new form of strange matter. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New data has pinpointed a new, more accurate time for the expected collision between our Milky Way galaxy and the giant neighbouring M31 galaxy in Andromeda. Instead of occurring around 3.7 billion years from now as previously calculated, the new data suggests the impact will occur around 800 million years later, in about 4.5 billion years' time, and rather than a head-on collision, it'll be more of a glancing blow. The new results are based on a detailed examination of data from the European Space Agency's Gaia satellite. As well as studying the stars in our Milky Way galaxy, Gaia's powerful eyes have also been looking beyond and exploring two nearby galaxies, Andromeda M31 and the Triangulum galaxy M33. It examines stellar motions within them and how they'll one day interact both with each other and with the Milky Way. Our Milky Way belongs to a large collection of galaxies known as the Local Group, and along with Andromeda and the Triangulum galaxy, makes up the majority of mass in the group. Astronomers have long suspected that Andromeda will one day collide with the Milky Way, completely reshaping our cosmic neighbourhood. However, the precise three-dimensional movements of the Local Group of galaxies remains unclear, painting a somewhat uncertain picture of our Milky Way's real future. The study's lead author, Roland van der Merel from the Space Telescope Science Institute in Baltimore, Maryland, says astronomers needed to explore the galaxy's motions in three dimensions in order to uncover how they've grown and evolved and what creates and influences their features and behaviours. Van der Merel and colleagues were able to do this by using the second package of high-quality data released by the Gaia spacecraft. Gaia is currently releasing the most precise three-dimensional map of stars in the nearby universe, and is releasing its data in stages. Previous studies of the Local Group have combined observations from telescopes including the Hubble Space Telescope and the ground-based Very Long Baseline Array in order to figure out how the orbits of Andromeda and Triangulum have changed over time. The two disc-shaped spiral galaxies are located between 2.5 and 3 million light-years from the Milky Way, and they're close enough to each other that they may be interacting. Two possibilities have emerged. Either Triangulum's on an incredibly long 6 billion-year orbit around Andromeda and has already fallen into it once, or it's currently on its first infall. Each scenario reflects a different orbital path, and thus a different formation history and future for each galaxy. While Hubble has obtained the sharpest view ever of both Andromeda and Triangulum, Gaia measures the individual position and motion of many of their stars with unprecedented accuracy. The authors combed through the Gaia data to identify thousands of individual stars in both galaxies, and then studied how these stars moved within their galactic homes. The stellar motions measured by Gaia not only reveals how each of the galaxies move through space, but also how each rotates around its own spin axis. By combining existing observations with the new data release from Gaia, the authors were able to determine how Andromeda and Triangulum are each moving across the sky, and they calculated the orbital path for each galaxy both backwards and forwards in time for billions of years. The velocities show M33 cannot be on a long orbit around M31, but is instead making its very first infall into Andromeda. And while both the Milky Way and Andromeda are still destined to collide and merge, both the timing and destructiveness of the interaction are likely to be very different from that previously expected. As Andromeda's motion differs now from what was previously estimated, the galaxy is now more likely to deliver a glancing blow to the Milky Way rather than a head-on collision. And it will happen about 800 million years later than previously anticipated. That's around 4.5 billion years from now, rather than the previously calculated 3.7 billion. The findings are crucial to science's understanding of how galaxies evolve and interact. There are unusual features in both M31 and M33, such as warped streams and trails of gas and stars. But if these galaxies haven't come together before, then these can have been created by gravitational forces felt during a merger. Perhaps they formed through interactions with other galaxies, or perhaps by gas dynamics within the galaxies themselves. You're listening to Space Time. I'm Stuart Gary. Scientists have identified 121 giant planets which may have habitable moons orbiting them. A report in the Astrophysical Journal identified the planets which could potentially host moons capable of supporting life. The findings will guide the design of future telescopes that can detect these potential moons and then look for telltale biosignatures in their atmospheres. Since the 2009 launch of NASA's planet-hunting Kepler Space Telescope, scientists have discovered more than 2,000 exoplanets, that is, planets beyond our solar system. The primary goal of Kepler was to identify planets orbiting in the habitable zones of their host stars. These are the Goldilocks areas around the star, where it's not too hot and not too cold, but just right for liquid water, essential for life as we know it, to pool on a planet's surface. Terrestrial planets have always been prime targets in the search for life beyond Earth. That's because some of them might be geologically and atmospherically similar to the Earth, the only example of life in the universe we know of. But another place to look are the many gas giants identified during the Kepler mission. While not candidates for life themselves, Jupiter-like giant gas planets in the habitable zones of their host stars could harbour rocky moons called exomoons, and some of these moons may well have conditions capable of sustaining life. There are currently 175 known moons orbiting the 8 planets in our solar system, and some of them, such as Jupiter's ice moon Europa and Saturn's ice moon Enceladus, are thought to contain large liquid water oceans deep under their frozen crusts. So gas giants orbiting other stars could also host large moons, some of which may also contain liquid water oceans. And scientists have speculated that at least some of these exomoons could possibly provide favourable environments for life, perhaps even better environments than Earth. That's because these exomoons would receive energy not just from their host star, but also from the heat reflected from their planet. Until now, very few exomoons have been confirmed. But now that astronomers have created a database of the known giant planets in the habitable zone of their stars, observations of the best candidates for hosting potential exomoons will be made to help refine the expected exomoon properties. One of the study's authors, Michelle Hill from the University of Southern Queensland, says follow-up studies will help inform future telescope design so that astronomers can detect these moons, study their properties, and look for signs of life.
So far, the search for habitable worlds was mainly focused on looking for Earth-like planets in the habitable zone of their star. And the habitable zone is the distance from a star where a world could be, and if there is water on the surface of the planet, it would be in a liquid form. So it wouldn't be too hot, so it's all evaporated off, or too cold, so it's all frozen. And we wanted to look, though, at whether moons could be more prevalent in the habitable zone of their stars. Already there's been a lot of interest in the moons of our solar system. The moons around Jupiter and Saturn have shown indications of liquid water oceans under their surfaces, and so could potentially be life-holding worlds. So we wanted to extend that to exoplanets and exomoons and see how many of these exomoons could potentially be in the habitable zone of their star. We had to do this by looking at the gas giant planets that the moons would be in orbit around. And so we did a study on how many of these gas giant planets reside in the habitable zone of their star, and how does that occurrence rate compare to Earth-like planets, which has already been studied in great detail.
It must be really hard determining which planets would have moons orbiting them.
Yeah.
Especially considering, from what we now know, it looks like our solar system is the outlier. It doesn't follow the normal practice of other solar systems.
Yeah, so we can do a couple of things. So if we look at our giant planets, Jupiter and Saturn, Jupiter has 69 moons and Saturn has 62, and Neptune and Uranus, even though they're smaller, they have quite a few moons as well. So because of the mass of these planets, they have the ability to sort of hold on to their satellites better than the smaller rocky planets do. And even though the habitable zone is a bit closer in, and so it would be under greater gravitational pull from the star on the planet, we would still expect there to be many moons for these giant planets. So maybe not in the 60s like Jupiter and Saturn because they are further out, but we still expect quite a few moons. And so we looked at the occurrence rates of the giant planets in the habitable zone, and we found that they are slightly less than that for Earth-like planets. But considering we expect then each giant planet to have multiple moons, then we can expect that there is at least as many or even more of these moons in the habitable zone as there are Earth-like planets. And so essentially our study has increased the number of potentially habitable worlds that we can observe out in the universe.
How do you find a moon around an exoplanet? Transit method wouldn't work. What about, are you hoping for some sort of a Doppler shift method to notice the slight change that in orbital velocity that a moon would cause on its host planet compared to the planet orbiting its host star?
Yeah, so the detection method that's going to give us the most fruit, I guess, it hasn't been found yet. There's a lot of different people trying different ways. Transit timing variation seems to be one of the most popular ones, where there's very, very slight variations in the transit of the planet because the moon might be in front of it or behind it. So it's sort of looking at the very edges of when the transit starts to happen and seeing if you can find a signature there. Imaging is a really interesting one. If we can get our telescopes up to a point where probably 100 times better than they are now, then imaging actually could be quite useful because these moons can be quite far away from their planet. So if we get the resolution to a point of about 400 times 10 to the negative 6 arc seconds, then we'll be able to image them. That's probably the two main contenders at the moment. So radio velocity detection or like Doppler detection, I don't think is going to have the kind of precision that we need to find these moons, unfortunately.
I guess the big hope would be at some stage in the future some sort of gravitational microlensing. Planets have been found that way.
Yeah, so actually microlensing is another one that people are trying to use. So I mean, watch this space.
Indeed. Okay, so where to now? You've crunched the numbers and now we sit back and wait for the technicians to build the telescopes?
I found in the following study 121 of these giant planets that reside in the habitable zone of their star. So these are already known planets. I just gathered them together in a list and ordered them in priority for which would be the best to observe for potentially hosting moons. And so from these 121 planets, the next stage is we're going to observe them with radial velocity detection methods because a lot of them, over 50 of them, showed indications of other planets in orbit with them that haven't yet been detected as well. So we'll be observing the stars to see if we can detect these planets, and then for the whole set we will be observing them to refine the orbital parameters of the planets to help in future exomoon detection. So the reason is because these giant planets are far out from their star if they're residing in the habitable zone, and so their observations of them so far are probably very limited because the orbital period is so long. And so the more detections that we can make of the planets, the better the parameters are refined, and then that will help in future exomoon detection.
These are dreaded three-body systems. Oh dear.
Exactly.
Well, when you talk about planets in habitable zones, what sort of stars are you actually looking at?
We've been focused mainly on stars similar to the Sun, so G and K stars, and also M stars, because these are less volatile and so they're easier to confirm that the planets are there and it's not just activity of the star.
The problem I have with M stars, I guess, is they're sort of a bit excitable, and consequently they tend to fry anything on the surface of planets orbiting nearby.
Yeah, exactly. And we also have a problem if we're looking at gas giants. Gas giants around M stars are less common just because of the mass isn't there to build the giant planet. There are a few, but it's just in our study we found that they're
good potential targets, I guess, just to test the hypothesis.
Yeah, exactly.
That's Michelle Hill, an astronomer with the University of Southern Queensland. I'm Stuart Gary, and this is SpaceTime. In a discovery that could provide new insights into the origins of mass in the universe following the Big Bang, scientists from the International J-Park E15 collaboration have used experiments with kaons and helium-3 to demonstrate for the first time the existence of an exotic nucleus containing 2 protons and a bound kaon. Kaons are a type of meson. The existence of mesons was first proposed back in 1935. And their eventual discovery was awarded with a Nobel Prize. Kaons, or K-mesons, are composed of an anti-quark and a quark pair, and they've recently become an important topic in research. Quarks are elemental subatomic particles and a fundamental constituent of matter. Quarks combine to form composite particles called hadrons, the most stable of which are protons and neutrons, which make up atomic nuclei. Due to a phenomenon known as color confinement, quarks are never directly observed or found in isolation, but only occur within hadrons, which exist either as baryons, such as protons and neutrons, or as mesons. Quarks have various intrinsic properties, including electric charge, mass, color charge, and spin. They are the only elementary particles in the standard model of particle physics to experience all 4 fundamental forces in nature: electromagnetism, gravity, and both the strong and weak nuclear forces. They're also the only known particles whose electric charges are not integer multiples of their elementary charge. There are 6 known types of quarks, known as flavors: up, down, top, bottom, sometimes called beauty, charm, and strange. Up and down quarks have the lowest masses. The up quark has a charge of 2/3, while the down quark has a charge of -1/3. A proton is composed of 2 up quarks and a down quark, while the neutron is made up of 1 up quark and 2 down quarks. Heavier quarks rapidly change into up and down quarks through a process of particle decay, the transformation from a higher mass to a lower mass state. Because of this, up and down quarks are generally stable and the most common in the universe, whereas strange, charm, bottom and top quarks can only be produced periodically in high-energy collisions, such as those involving cosmic rays or in particle accelerators. For every quark flavor, there's a corresponding antimatter counterpart or antiquark that differs only in some of its properties, have equal magnitude but opposite sign. Apart from the quarks and gluons that constitute the nucleons, there are also valence quarks which continually pop into and out of existence due to quantum fluctuations. Now, the thing with antiquarks and quarks, or the thing with all matter and antimatter in fact, is that they annihilate each other as soon as they come into contact. And kaons usually exist as virtual quantum particles that pop into and out of existence inside the nucleus. But under the right conditions, these virtual quantum particles could become real bound particles in a nucleus. And for at least a fleeting moment before they annihilate each other, they could become part of an exotic nucleus, along with the typical neutrons and protons found in the nucleus. That's because there is a slight time lag before the quark and antiquark annihilate each other. Understanding how this happens could provide fresh insights into mysteries such as the origin of mass and the quantum phenomenon of color confinement. In quantum chromodynamic theory, color charge is completely unrelated to the everyday meaning of color. It simply uses the primary color labels, red, blue, and green, to describe the properties of different types of quarks and how they interact through gluons with their corresponding antiparticles. A particle with a red, green, or blue charge has a corresponding antiparticle, in which the color charge must be the anticolor of red, green, or blue respectively, for the color charge to be conserved in particle-antiparticle creation and annihilation. In quantum chromodynamics, color confinement is the phenomenon that quarks must be bound together in groups that can't exist in isolation. Instead, 3 different colored quarks, red, green, and blue, must combine to form a baryon, such as the protons and neutrons found in atoms, while 2 quarks, made up of a color and anticolor pair, combine to form a meson. Interestingly, if you try to pull these quarks apart, the strong nuclear force holding them together gets even stronger, sort of like pulling on an elastic band. Eventually, the energy required becomes so great that a new quark-antiquark pair are created as per Albert Einstein's famous mass-energy equation equals mc². So to investigate this, the authors tried an experiment in which they attempted to bind a kaon to a nucleus. To do the experiment, the researchers decided to use a helium-3 target. That's a nucleus made up of 2 protons and a single neutron. By knocking out a neutron from the helium-3 target, the authors were able to greatly reduce the energy of the kaon by using the recoil of the ejection and replacing the neutron with the kaon, thereby forming a tightly bonded nucleus with 2 protons and a single kaon. Reporting in the journal Physics Letters B, the study's lead author, Masahiko Iwazaki from the Riken Cluster for Pioneering Research, says the experiment shows that mesons can exist in nuclear matter as a real particle, like sugar that's not dissolved in water. He says it opens up a whole new way of looking at and understanding nuclei. Understanding such exotic nuclei will give science insights into the origins of the mass of the nuclei, as well as how matter forms in the core of neutron stars. The authors now intend to continue their experiments using heavier nuclei to further their understanding of the binding behaviour of kaons. This is SpaceTime. I'm Stuart Gary. The planet Earth has had another visit from a 100-metre-wide asteroid the size of the Statue of Liberty, which has been making repeatedly close flybys of our planet for many years now. The asteroid 2013 RV9 passed the Earth last Wednesday at around 6.8 million kilometres. It might not sound like much, but in astronomical terms, it's a hair's breadth. That's also a lot closer than previous encounters, which included one at 54 million kilometres back in 2003, another at 57 million kilometres in 2004, and a third less than 35 million kilometres away in August last year. NASA describes this giant space rock as a NEO or near-Earth object, a category which includes comets, asteroids and meteors that pass through the Earth's neighbourhood and are well worth keeping an eye on. And there'll be plenty of opportunities for that too. 2013 RV9 will swoop past the Earth again in 2022, 2023 and 2024. Meanwhile, astronomers have discovered another asteroid, this one looping through the inner solar system on a really strange exotic orbit. The unusual object is among the first asteroids ever found whose orbit is confined almost entirely to within the orbit of Venus. The asteroid's existence hints at potentially significant numbers of space rocks arcing unseen in uncharted regions near the Sun. Designated as 2019 AQ3, this object was detected by the Zwicky Transient Facility Sky Survey camera mounted at the Mount Palomar Observatory southeast of Los Angeles. This asteroid has the shortest year of any recorded asteroid, with an orbital period of just 165 Earth days. Its orbit's also highly unusual for an asteroid. Most asteroids orbit around the Sun roughly on or about the ecliptic, that is the imaginary plane around the Sun on which all the planets orbit. But 2019 AQ3's orbit's angled vertically, taking it well above and below the plane of the ecliptic. That's the sort of orbit comets occasionally follow. Over its short year, 2019 AQ3 plunges inside Mercury's orbit and swings back up just outside Venus's orbit. One of the study's authors, Quanji Yi from Caltech, says the asteroid also appears to be unusually big, with a diameter estimated to be around 1.5 kilometres. A chief goal of the Zwicky Transient Facility is finding NEOs or near-Earth objects, especially those between 10 and 100 metres in diameter. Not monstrous in size, but still large enough to destroy a city were they to collide with the Earth. Of all these potentially Earth-bound space rocks, the most concerning are those which come from the direction of the Sun. That's because they're difficult to find, because they'll get lost in the glare of the Sun and are hard to measure. These small asteroids are only bright enough to be detected during the very short period of time that they're really close to the Earth, but that's also when they're moving at their fastest, making them difficult to track. To have any hope of locating these potential threats, the sky needs to be scanned very frequently, and the Zwicky Transient Facility surveys the entire Northern Hemisphere every 3 nights. Finding NEOs before they find us has long been a goal for astronomers. So far, of the more than 3,400 asteroids discovered, nearly 300 are classified as near-Earth asteroids, and the Zwicky Transient Facility has discovered 50 of them. 2 of these, designated as 2018 NW and 2018 NX, were discovered in July last year, just before they swooped past the Earth at a distance of only 113,000 kilometres. Thankfully, the newly discovered 2019 AQ3 is orbiting at a somewhat more comfortable 354 million kilometres distant. For now, 2019 AQ3 is being placed among a peculiar population of asteroids usually referred to as the Atra or apohelate asteroids, which have orbits interior to Earth's orbit around the Sun. Learning more about both known and new-found terrors, for example things like their size, is an additional goal of this project. The true size of 2019 AQ3 is not yet discernible, but as we said earlier, limited readings suggest that the asteroid's brightness, mass and density suggest it could be about 1.5 kilometres wide. If it is that big, 2019 AQ3 would be one of the largest members of the Atira group, at least one of the largest known members. Also, finding more space rocks in AQ3's neck of the woods would lend more credence to the long-held idea of volcanoids, asteroids that swarm inside the orbit of Mercury. The hypothetical population's name derives from a likewise hypothetical planet called Vulcan. Bearing no relation to the fictional world of Mr. Spock in Star Trek, Vulcan was proposed in the 19th century as the planet closest to the Sun, whose gravity would explain anomalies observed in Mercury's orbit. Albert Einstein's gravitational framework, the theory of general relativity, eventually explained away these anomalies in 1915, thereby nixing the Vulcan conjecture. Although the Zwicky Transient Facility will not have the ability to find volcanoids, its observing prowess, coupled with that of future telescopes, will enable scientists to at least examine an uncharted region of the inner solar system. But as well as looking inwards, the Zwicky Transient Facility's also been able to look outwards well beyond our solar system. In fact, it's discovered over 1,100 supernovae while observing more than 1 billion stars in the Milky Way galaxy. So many discoveries, in fact, that 7 new papers about the earlier results from Zwicky have now been accepted for publication in journals such as Publications of the Astronomical Society of the Pacific. This is SpaceTime. I'm Stuart Gary. A United Launch Alliance Delta IV Heavy has thundered into orbit, carrying with it a new spy satellite for the National Reconnaissance Office. The NROL-71 mission lifted off from Space Launch Complex 6 at the Vandenberg Air Force Base in California. It was only the third time the 71-metre-tall Delta IV Heavy had launched from the West Coast complex.
Rock, range is green. Second stage, LH2 secure at flight level.
Status check.
Go Delta.
Go NROL-71.
Roll for ignition.
T-minus 10, 9, 8. We should have ignition. 6, 5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Delta IV Heavy rocket with NROL-71 for the National Reconnaissance Office.
Vehicles beginning the pitch over maneuver.
You are hearing the voice of Patrick Moore providing launch vehicle ascent data.
Now 20 seconds into flight, seeing good chamber pressure across all 3 R68A engines. And core boosters beginning to throttle down to the partial thrust mode as expected. Core boosters reach partial thrust. Chamber pressures continue to look good across all 3 R68 engines. Core booster in partial thrust mode. Port and starboard boosters in the full thrust mode. Vehicle is now passing max Q, maximum dynamic pressure. And vehicle is now past Mach 1. Delta IV is now supersonic. Now 1 minute, 30 seconds into flight. Chamber pressures on all 3 R68A engines continue to look good. Core booster in the partial thrust mode. Port and starboard boosters in the full thrust mode. Launch vehicle is now 12 miles in altitude, traveling at almost 1,600 miles per hour. Chamber pressures on all 3 engines continue to look good. Coming up on 2 minutes into flight. Second stage attitude control system press valve has been opened. System now pressurizing to flight levels. Response looks good. Chamber pressures on all 3 engines continue to look good. Vehicle has now gone to closed loop guidance. Vehicle body rates look good. Just over 3 minutes now remaining in the boost phase of flight. Engine operating parameters continue to look good. The Delta IV rocket now weighs just 1/2 of what it did at launch, burning propellant at a rate of almost 5,000 pounds per second. 2 minutes, 55 seconds in, vehicle body rates continue to look good. Now at 3 minutes, vehicle is now passing Mach 5. Vehicle body rates continue to look good. Chamber pressures on the R68A engines continue to look good. Now coming up on 3 minutes, 20 seconds into flight. Just over 30 seconds now remaining until strap-on booster engine cutoff. Vehicle is now passing Mach 10. Chamber pressures on the R68A engines continue to look good. And port and starboard booster engines now throttling down to partial thrust in preparation for cutoff as expected. And we have cutoff of the strap-on engines, standing by for separation. And we have good indication of separation of the port and starboard strap-on booster. Core booster is now throttled back up to the full thrust mode. Engine response looks good. 4 minutes, 10 seconds into flight. Chamber pressure on the core booster in the full thrust mode looks good. Upper stage lock system has begun boost phase chill down sequence to begin thermal conditioning of the upper stage engine. Now 1 minute remaining in the boost phase of flight. And upper stage fuel system has begun boost phase chill down. Core booster continues to look good in the full thrust mode. Coming up on 5 minutes into flight, little over 30 seconds now remaining until BECO. Vehicle body rates continue to look good. Chamber pressure continue to look good on the core booster. Now 5 minutes, 20 seconds, standing by for core booster throttle down shortly. Core booster is now throttling down as expected, standing by for BECO. And we have BECO booster engine cutoff, standing by for stage separation. And we have good indication of stage separation. Nozzle extension is now deploying. We have pre-start on the RL-10, standing by for ignition on the RL-10. We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good. Standing by for payload fairing jettison. And we have good indication of payload fairing jettison. Chamber pressure continuing to look good on the RL-10 engine. This first burn of today's mission will last approximately 12 minutes, 6 seconds.
The National Reconnaissance Office operates America's intelligence-gathering spy satellites. Previous West Coast Delta IV Heavy launches have involved Crystal or Keyhole 11 high-resolution imaging satellites, flying to the southwest to place their spy satellites into near-polar sun-synchronous orbits. It's these satellites upon which NASA's Hubble Space Telescope's based. It just points upwards instead of down. In fact, the CIA offered NASA 2 of these Keyhole satellites as Hubble replacements. One of the unusual things about the launch of the NROL-71 spy satellite was that instead of travelling to the southwest, its trajectory was to the southeast. That could indicate that instead of being a Keyhole satellite, it could be an electronic signals intelligence or eavesdropping satellite, flying in a Molniya orbit. Molniya orbits are lopsided to allow increased dwell time at higher latitudes and over the poles. A top-secret US Air Force X-37B space shuttle has just completed its 500th day in orbit. The Delta-winged autonomous spaceplane, originally developed to be launched in the payload bay of NASA's now-retired space shuttle fleet, is on its 5th classified long-duration mission. All previous flights of the OTV or Orbital Test Vehicle program have established new records, with the last flight of the spacecraft's sister ship staying in orbit for 718 days. That mission, known as OTV-4, was launched from the Cape Canaveral Air Force Station in Florida aboard a United Launch Alliance Atlas V rocket back in May 2015. It finally landed at NASA's Kennedy Space Center at Cape Canaveral in May 2017, marking a combined total of 2,085 days in space for the 2 space shuttles in the OTV program. The current mission, OTV-5, began back on September the 7th, 2017, when the spacecraft was launched from the Kennedy Space Center's Launch Complex 39A aboard a SpaceX Falcon 9 rocket. All operations involving the X-37B are highly classified. However, OTV-5 was spotted by amateur satellite hunters last August. It was flying at an altitude of around 320 kilometers. That's low enough to suggest some type of intelligence gathering operation. And that's interesting because the US Air Force claims all OTV flights are designed to test new materials and systems in space, with OTV-5 carrying an advanced structurally embedded thermal spreader developed to test experimental electronics and oscillating heat pipe radiators in the long-duration space environment. But other reports suggest the X-37Bs are actually being used to collect, repair and modify satellites in orbit. And when we say modify satellites, I guess that, well, doesn't necessarily mean it's got to be American satellites. While the OTV-5 mission remains in orbit, a United Launch Alliance Atlas V rocket is already being prepped for the OTV-6 mission. That's expected to fly from Cape Canaveral before the end of the year. You're listening to Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. Australia has just had its warmest January on record. But in case you needed more evidence of long-term climate change, the World Meteorological Society has just confirmed that the past 4 years since 2015 have been the warmest ever recorded. The World Meteorological Organization consolidated and analysed data from 5 international datasets, finding the average global surface temperature in 2018 was around 1 degree Celsius higher than the pre-industrial baseline. In fact, the warmest 20 years on record have been during the past 22 years, but the past 4 years in particular have been exceptional. Meanwhile, a separate report by NASA and the National Oceanic and Atmospheric Administration, NOAA, has found that global carbon dioxide levels have increased 46% since the late 19th century. Carbon dioxide is the dominant factor causing global warming. The NASA-NOAA study also found that melting ice is increasing sea levels around the world. It found that while ice melts in the ocean, heat also causes water to expand. In fact, since 1880, sea levels around the world have risen approximately 203 millimetres. That's 8 inches on the old scale. Also, since 1880, scientists have been able to put together a consistent record of temperatures around the planet. It also confirmed that temperatures have increased even faster since the 1970s, all as a direct result of increasing greenhouse gases in the atmosphere. Well, while Queensland struggles to clean up after record-breaking monsoon rains and deadly floods, the rest of Australia continues to experience drought conditions. The situation is now so bad that Australia's largest city, Sydney, has now activated its water desalination plant. It's the first time this has happened that's not been a trial or test. Now, a report in the journal Nature Climate Change says the lack of winter rain across the southern hemisphere is likely to continue as temperatures continue to rise. But it says the effect may be just temporary. See, scientists have found that this drying trend could start to reverse once temperatures begin to stabilise around the year 2100, even if it's warmer overall. It seems the drying trends are linked to rises in temperature rather than it just being warmer overall, and the research suggests that winter rains could return after 2100 or the year 2200, depending on how long emissions continue to rise. Australian cybersecurity services are investigating a new cyber attack which has targeted federal members of parliament. Early investigations are pointing towards a foreign government being behind the attack, which appears to be targeting the parliamentary network used by members of parliament and their staff to store background information, databases and emails. The speculation is that those behind the hacking are searching for potential blackmail material on MPs' computers which could be used for political interference in the run-up to the next federal election. In 2011, China was found responsible for several high-profile hacks on Australian government systems, including the breaching of the Parliament's computer network, which allowed Chinese spies to read the emails of MPs and their staff for months. Scientists have developed a new pill that, once swallowed, can attach itself to the inside of the stomach, injecting drugs straight through the stomach lining into the gut. A report in the journal Science says the shape of the capsule was inspired by the leopard tortoise's ability to get back on its feet after being tipped over, which helps the capsule orientate itself into the stomach wall. This new method of drug delivery would allow fragile drugs like insulin, which would be broken down by the stomach, to make it safely into the intestines rather than being administered by injection or IV. Physicists have created an exotic electron liquid. A report in the journal Nature Photonics says that by bombarding an ultra-thin semiconductor sandwich with powerful laser pulses, physicists with the University of California, Riverside have created the first electron liquid at room temperature. The achievement opens a pathway for the development of the first practical and efficient optoelectronic devices to generate and detect light at terahertz wavelengths between infrared and microwaves. Such devices could be used for applications as diverse as communications in outer space, cancer detection, and scanning for concealed weapons. The research could also enable exploration of the basic physics of matter at infinitesimally small scales and help usher in a new era of quantum metamaterials whose structures are engineered at atomic dimensions. A study of metal contamination in southwest Tasmania by the Australian National University has found that lakes in the Tasmanian Wilderness World Heritage Area are contaminated with dangerous metals at levels among the highest in the world. The findings, published in the journal Science of the Total Environment, found dangerous levels of lead, copper, arsenic and cadmium were found in all 6 lakes in the wilderness region. In fact, it found readings exceeding the highest allowable levels for sediment guidelines for Australia and New Zealand. The researchers found the metal contaminants had travelled 130 kilometres downwind of the historic mining sites of Queenstown and Rosebery. If a fish can recognise itself in a mirror, does that mean it's self-aware? Well, a study published in the journal PLOS Biology has reported research in which fish were passing the mark test, attempting to remove artificial marks on their body while looking in a mirror. This mark test is regarded as the gold standard for determining whether animals are self-aware. And self-awareness is a trait thought to only be held by humans, primates and some other mammals. So the fish findings call into question whether passing the test automatically bestows self-awareness on an animal. An accompanying editorial by a primate researcher argues the definition is too black and white, and that self-awareness may be more like an onion, developing in layers rather than appearing all at once. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.